Alright, so for this next one, we're going to make sure that we think about this logically. If I were to draw out the base, this base would look like this, being 18, 18, 10, and 10. So when I think about this lateral face here, this slant height here, realistically it comes from a triangle that looks like this. This being 12. Remember that this line is parallel to this line, so this is 9 because it's half of 18. And this is the slant height 1 that I need to find. Now, if I look at it this way, there is actually a completely different slant height here. If this whole thing measures 10, then this length here measures 5, and this is slant height 2 that you don't know. So what you have here are two different slant heights. So when you do this, you need to take that into consideration. This one will be slant height 1, and this one will be slant height 2. So first of all, I'm going to find slant height 1. So slant height 1 will be slant height 1 squared is equal to 9 squared plus 12 squared. So this gives me this slant height 1 squared is 225. So slant height 1 is equal to 15. I skipped some steps, but if you need, put it on pause and go through all of them and see if you come up with the same thing. Slant height 2 will be 5 squared plus 12 squared equals your slant height squared. Second one. So this one, the second one gives me 169. So slant height 2, not squared, but 2 is 13. So I have slant height 1, which is 15, 15, and slant height 2, which is 13 and 13. So now I'm going to start solving this out. So my surface area is equal to my base plus 2 lateral faces plus another 2 lateral faces. And this, it's split up because you're doing the opposite ones together and then the other 2 opposite ones together. So my base is 10 times 18 plus 2 times 1/2 times 10 times 15. That's for this one. That is for this one and this one. Plus 2 times 1/2 18 times 13. So that's, this one is for the top and the bottom. So this gives me 180 plus the 1/2 and the 2 here are going to cancel out. So that will give me plus 150. This times 2 and 1/2 will cancel out, which will give me 234. I add all of these together to give me 564 feet squared. The next one. This is just a regular cone. I started out with a triangle and I've rotated around this axis right here, and that created a cone. So I'm just going to use surface area, my formula, pi r squared plus pi rl. And if I did rl pi in class, you're multiplying, so it doesn't matter which order. So this gives you pi times 1.2 squared. That's the radius. And then you have plus pi. My radius is 1.2. And my slant height is 2. This gives me pi times 1.44 plus pi times 2.4. I could rewrite this as 1 and 4400 plus 2 and 4/10 pi. Because these are both in terms of pi, we can consider them like terms. So this would be 3 and 84/100 pi unit squared. And the last one on this page, if I were to sketch this out, I have a radius of 3, a height of 14, and in order to do this, I would have to find this slant height. So in order to find this slant height, I'm going to use Pythagorean theorem. So L squared equals 3 squared plus 14 squared. So L squared equals 205. So L equals the square root of 205. I'm going to do this as an exact answer, because realistically, if you were rounding, you shouldn't round until the end. So my surface area formula is my base pi r squared plus pi r L. So this gives me pi times my radius is 3 squared plus pi. My radius is 3 and my slant height is the square root of 205. 3 squared is 9. So this is 9 pi plus 3 pi the square root of 205. If you were writing it the way I want you to write it, this would be your answer, and it would be unit squared. Some of you, this is approximately 163.217 thousandths unit squared.